All right. On the hip-hop note, when I was young, I did in fact perform on the stage a couple of times, but then I met my beautiful wife. We had a daughter who is turning 17 years in a couple of weeks, went to Thailand, stayed here for 11 years. So for some reason, hip-hop career didn't happen. A career in software development happened instead, which I'm probably compensating for on this stage now. All right, jokes aside, hi, I'm Alex. I'm the CTO at Blue Thumb Art, Australia's largest online fine art marketplace. And yes, it is a Ruby on Rails monolith that's been evolving for about 14 years. On the photo behind me, you can see my young and tired self wearing staff lanyard on the first ever RubyConf Thailand back in 2019, which was a privilege to volunteer for. In turn, Blue Thumb had the privilege of being one of the sponsors for this very conference in 2023. And I have a photo of Matt wearing a conference lanyard with Blue Thumb logo on it. So if you have ever considered sponsoring this event, pretty please do. It will certainly pay off. Okay. That photo would probably benefit from a bit of upscaling. Today, I will show how we turned phone quality listing photos into saleable canvas prints while keeping artists safe, rewarded, and in control. This talk is part ethics, part production engineering, part how upscaling actually works with practical lessons you can reuse for your own experiments and businesses. One of the benefits you can see an experienced person in front of a mic. One of the benefits of working in an art-related startup is looking into beautiful objects every day. And beautiful things makes your life better, right? So I can promise you anything. If I can promise you anything today, it is this presentation having more beautiful art than code samples. The presentation cover photo and the one behind me are from our print-on-demand launch exhibition in March 2025. We staged it so visitors could compare original artworks against canvas prints side by side and try to spot differences. Canvas print, by the way, is a premium wall art format, heavy cotton canvas stretched over a deep wooden frame. It's textured, durable, and low glare compared to posters and most paper prints. And print on demand, in our context, is a service we built what lets artists sell high-quality reproduction of their art with almost zero effort. Uploading where already have, make a sale, and we handle the pipeline, including upscaling, or at least that's the promise. Here a close-up. One is an original artwork, one is its printed reproduction. Not the best art example, but my talk is after a coffee break, and I'm a coffee addict, so pick this one. Raise one hand if you think the canvas print is on top. Okay, yeah, that's good. Raise both hands if you think the canvas print is on the bottom. It was easy, right? So apparently the canvas print is on the bottom. What gave the canvas print away? The guy in yellow looks like Roland to me a bit for some reason. Don't know why. Back to samples. First, it's flatter. The original has real paint thickness, bumps and strokes, especially around high contrast edges. The print can mimic texture, but it is still a surface illusion. Second, colors feel a bit less alive. Originals often have subtle glow from pigment, varnish, and light interactions. Prints can be extremely good, but the energy shifts slightly cooler or more uniform. Third, in dark regions, the print tends to collapse, tiny variations into smoother patches. You lose those micro accidents of real paint. These are also the kinds of places where upscaling and compression artifacts become visible. Full disclosure, the canvas print you saw was produced from the original artworks preview attachment, basically the same kind of listing photo you are seeing here. So yes, some artifacts are from the original photo itself: lighting, compression, phone camera noise, classic garbage in, garbage out problem. Our job is to take that input, run it through a printability assessment, and if it passes, upscale it to the pixel dimensions required for real-world production. So why are we talking about canvas prints at Ruby conference? Because this is a real story about taking messy real-world problem, art plus trust plus production, and building a pipeline that works at scale. Blue Thumb hosts tens of thousands of artists and listings, and print on demand became a way to give artists ongoing royalties with minimal extra effort. In this talk, I will cover the ethical boundary we needed to draw, the end-to-end pipeline, and then a simple mental model for upscaling algorithms. We have already set the stage for the print versus original demo. Next, a quick tour of the ethical concerns that artists raise and how we designed around them. Then we will walk the pipeline end to end, from listing photo to delivered canvas. And finally, upscaling algorithms, not as math lecture, but as a set of mental models you will remember. My goal isn't to claim novelty, it's to share practical lessons from applying AI or sometimes machine learning to the transition from pixels to physical objects, and hopefully spark similar experiments in your communities. Speaking of side projects over the holidays break, the print-on-demand idea started around 2022, and we explored it seriously in early 2023. At that time, asking artists to upload HD scans sounded reasonable until reality hit. Professional print-ready scans are expensive. It's on average 240 to 150 Australian dollars per A1 scan, and most artists won't do that work unless prints are already a proven income stream. Meanwhile, the broader AI tooling have accelerated, including easier access to AI services and better image enhancement. And that let us pivot from upload new HD scans to use what you already have, listing photos. That pivot made print on demand zero effort for artists, and the remaining challenge became bridging digital inputs to physical production. As soon as we started talking publicly about AI-infused print on demand, artists on the platform got more concerned than excited. And honestly, that reaction makes sense given the last few years of generative art hype and backlash. So we had to build the pipeline in a way what artists could trust, not just technically correct, but ethically defensible. Let's quickly review the big three concerns we heard again and again. Concern number one, consent, is the emotional core. My work was used to train models, and nobody asked me about. High-profile flights like Jetty Images versus Stability Eye made the issue mainstream. Rights holders arguing that their content was used without permission and that model providers should be accountable. And the artist class action space became a symbol of the same fear. Posting online starts feeling like feeding the machine. So our boundary was simple. We require explicit opt-in consent for prints, and we treat training data as something that must be ethically sourced. Concern number two, even when outputs aren't direct replicas, creators argue what value is being extracted from their craft. Some platforms responded with licensing payouts approaches, like Shutterstock's contributor fund tied to data licensing. Adobe positioned Firefly as trained on Adobe stock plus openly licensed plus public domain and introduced contributor bonuses. And interestingly, software creators are having a parallel conversation. AI can absorb documentation and reduce direct traffic or attention for creators. So the value extracted feeling is spreading beyond art now. In our world, we wanted the simplest possible rule. If a print sells, the artist gets paid, consistently, and the print is treated as a royalty stream from their intellectual property. Concern number 3, the practical fear. Can I protect this artwork and can a client safely buy it? In the US, the Copyright Office has repeatedly emphasized a human authorship requirement. Purely AI-generated material generally isn't copyrightable, and AI-assisted works require meaningful human control and disclosure. Courts have reinforced that AI alone can be the author. Our stance here, we are not generating new art, we are transforming an artist's existing work into a faithful reproduction format and keeping the artist in control of participation. Now the fun part, the full chain of business rules, events, and tech, what turns a digital listing photo in the physical canvas print. At high level, acquiring consent, original artwork sale event, classification, smart autocrop, duplication into print listings, upscale on demand, bleed extension, orientation marking, then production and delivery. Some steps happen proactively before a print is ever purchased. Others happen only after the first purchase to control cost. And yes, we will call out our production partner, which is Vistaprint, here because the real world has constraints and real-world people helped us a lot with the project. We needed a model that answers a non-artistic question, not is it beautiful, but is this photo good enough as a production source. We used a practical approach. Take a data set of opted-in artist uploads, label common cases like printable, in situ, framed, and so on, and train a lightweight classifier. We built it using Clarif AI, transfer learning, embedding classifier style workflow, and essentially leveraging pre-trained visual embedding and training a classifier layer on our labels. The model isn't perfect, but it gives us a probability score, and we continuously improve it using real-world cases. On the photo behind me is an artwork recognized as printable. It has a flat surface, no frame, no extra object on the picture, and even lighting. In contrast, unprintable examples. In situ photo, and you won't believe it, but nobody would probably want a print of somebody else's interior, but humans are strange beings, and sometimes it happens, and people order that stuff. Photo with a frame and other artifacts on the picture, which apparently will be recognized as unprintable. Diptychs, triptychs, and so on. Again, in situ alike, some collectors might want to purchase prints based on them, but likely by mistake. And yet another basic in situ variation. Next step is cropping. Our print partner supports specific size aspects, templates, so we must crop images to match and still look good. We used Cloudinary's smart cropping tool with automatic gravity. It detects the main area of interest and crops around it for target aspect ratio. If we are lucky, we generate 4 good crops. Then artists can disable crops they don't like or replace them with scans later on if they want maximum fidelity. Step 3, we don't upscale upfront. Doing it for every eligible listing would burn compute and storage. Instead, we upscale only when a specific print size is purchased for the first time. After testing a few options, we use Topaz Labs Image API, where docs describe standard V2 as a general purpose model, balancing detail, sharpness, and noise reduction. Operationally, it's just an API workflow. Upload, all status, download result with rate limits and retries. Just a quick comparison of an image before upscale and an image after upscale. Not sure if it is visible here, but trust me, second photo is better. Right, now we leave pure digital and printers care about physical units and pixel density. We had to hit exact pixel dimensions. It is dictated by production templates. Otherwise, you get scaling, softness, or unexpected trims. Once you treat the template as a contract, the rest is just engineering. Compute required pixels, upscales to match, validate, and proceed. By surprise step, full bleed and trim safety. Printers intentionally print extra image beyond final cut because cutting isn't perfectly aligned. Without bleed, you get thin white lines. Canvas adds another gotcha. Part of the image wraps around the frame and falls to the back. Edge pixels can varnish into corners or under staples. So we wrote a small Ruby service using libvips, extend the image by mirroring the edges, including corners, then blur the added borders so it becomes a soft continuation instead of an obvious reflection. Our engineer Maria's creative insight here was basically a production version of a trick used in graphic game dev workflows, hide seams by extending texture beyond the visibility. Same idea, different medium. On the photo, after cropped, upscaled, full bleed trimmed file, almost ready for production. When we hit a very human problem, print direction. In the digital world, up is obvious. On the production line, especially with abstract art, it is not. Someone has to attach the hanger, and if they guess wrong, the customer receives a sideways artwork. So we add a simple overlay marker, arrows at the top, to indicate the intended top edge. Compared to the earlier steps, this is hilariously easy, and it prevents a lot of real-world mistakes. Finally, it's time to send production-ready assets and metadata through the partner API. The upscaled file, selected size, SKU, frame color, shipping address. From here, it is out of our hands, and honestly, it's impressive. Production lines, physical QA, packaging, logistics, everything is done by our partners. Now, the most interesting part, what upscaling actually is. Upscaling or single image super resolution means enlarging an image and generating detail what wasn't present in the original pixels. At small scales, it is easy. At print scales, it becomes guesswork. The core question, what pixels should exist between these pixels? Different methods answer that question differently, some conservative, some creative, and that matters a lot for the fine art. Before AI, upscaling meant interpolation. Resample based on neighboring pixels. Nearest neighbor gives blocky pixel art, bicubic, but usually blur fine detail. If we look for analogy, you take a small painting and physically stretch the canvas. You don't reprint anything, you just spread what exists. That's why it is stable, no hallucinations, but it is also why it disappoints at large print sizes. The magic detail simply isn't there. This is the oldest model, if we call it model. In the 1980s, multi-frame signal processing techniques enabled modest super resolution, and by 2003, example-based patch methods appeared. So in conclusion, these methods are deterministic and fast, but cannot invent new detail. Their outputs are often described as blurred or stepped artifacts. Next model is CNN, or convolutional neural networks-based upscaling. CNN upscalers learn from pairs, take a high-resolution image, downscale it, and train the network to predict the original. The analogy here is you are restoring a mosaic. Some tiles are missing, but you have seen thousands of similar mosaics before, so you know if tiles look like this, the missing ones are probably that. You fill in the gaps carefully and conservatively. They are great at reconstructing edges and textures in a controlled way, but because they often optimize for pixel level losses, outputs can look clean but a bit smooth. The first deep learning SR model, SRCNN, was released in 2014, demonstrated what a simple 3-layer CNN can learn to map low-res to high-res images. This spurred a wave of deeper architectures like VDSR in 2016, introduced a very deep CNN, and EDSR 2017 optimized for residual networks for super resolution. In conclusion, if you value fidelity over flair, CNN-style methods are often the safest AI step up from interpolation. That's probably my favorite model, and I will explain why in a second. It's called GAN, or Generative Adversarial Network-Based Upscaling. GANs changed the goal from pixel accurate to looks real to humans. Two networks, the generator produces an upscaled image, the discriminator tries to spot it as fake. Through that adversarial training loop, the generator learns to create texture what convinces humans, even if it wasn't truly in the input. So the reason why I probably love that model the most, because it reminds me of something very familiar to everyone working in teams with more than one developer, code review. So you can think of generator as a developer submitting a pull request. Discriminator is a reviewer who rejects anything what doesn't look real. Over time, the dev learns what passes review, and the output looks great. The strength of GAN upscalers is the level of detail and realism they can produce. They tend to recover textures what make the image pop, no more overly smooth faces or washed out of textures. Instead, you get crisp edges and intricate details. However, the big caveat with GAN-based super resolutions is what it can hallucinate. Details what were never in the original. The network might add different pattern of fur on an animal or extra strands of hair what weren't actually there, simply because those details would fool the discriminator. In terms of timeline, in 2017, SRGAN, the first super resolution model trained with an adversarial loss, was introduced. SRGAN used a CNN generator plus a discriminator to encourage realistic textures. In 2018, SRGAN, enhanced SRGAN, I know it sounds similar, but like enhanced is in front of SRGAN, which makes it SRGAN, improved the architecture, ResNet blocks, realistic losses to yield even sharper details. Since then, many variants appeared, ESRGAN Plus, Real ESRGAN, Rank SRGAN, etc. And when I was researching for the project, there was actually a library of possible models already pre-trained, so you can download them and experiment more. Last but not the least, diffusion models approach upscaling as iterative refinement. Instead of one shot, they denoise repeatedly, gradually producing a high-resolution image guided by the low-resolution input. The best analogy, you start with fog of static and slowly carve an image out of it, guided by the small original. Beginning in 2021, diffusion models have been applied to super resolution. They call it Google's SR3, was released in 2021, and it was the first pure diffusion-based super resolution model. Around 2022, large latent diffusion models, stable diffusion, imaging, started including super resolution pipelines. A big advantage in that diffusion models allow some flexibility. For example, the ability to guide the generation with text prompts or other conditions if one wants to modify and enhance the image during upscaling. However, diffusion models share similar pitfalls to GANs. Since they generate content, they can also hallucinate or alter image elements if not carefully controlled. They are probabilistic, meaning if you run it twice, you might not get exactly the same details each time unless you fix a random seed. This approach can be stunning, but it is usually slower and can drift creativity if not constrained. So if you want to remember one slide, remember this one. Traditional model equals safe resize. CNN, learned reconstruction, usually faithful. GAN equals realism boost, but can be inventing things. And diffusion, iterative refinement, often incredible, but slower and can drift. In production, you often chain these ideas, classify the input, choose the method, maybe denoise first, then upscale, then do print-specific processing. And in our case, we used a programmatic API-based upscaler Topaz standard v2 because operational simplicity matters as much as the model family. In conclusion, few lessons learned. First, ethics isn't a bonus slide, it's survival, especially when you deal with big audience of artists. Consent, compensation, and ownership are not abstract topics when you users are creators. Second, the pipeline is the product. The model is only one step. Real success is handling crops, bleed, orientation, templates, retries, QA, and delivery, and the messy mid-world constraints. Third, AI isn't replacing us yet. It's multiplying what small teams can do, especially when you combine services thoroughly. And yes, AI helped with this presentation research, but the hardest part was extracting the story from my own memory and experience. No model can do that for now yet. Neuralink, wink, wink. I think if this talk gives you one push, build something that crosses the boundary from digital to physical in your own community. It's hard, but it's magic when it works. That's it. Thank you for having me.